Hello, my name is Rob O'Connor from the Department of Computing and Mathematics at WIT. I'm the course leader for the Level 8 Bachelor of Science degree in Applied Computing. I'm here to give you some information about the course, outline what's involved in the area, and hopefully help you to make a more informed choice about studying applied computing at WIT. As I go through this material, you might have questions you'd like to ask about the course or the computer science discipline in general, or something about the way we do things in Waterford or whatever. If I don't answer your question directly in the video, I'll give out contact details at the end where you can email in your queries afterwards. And questions are good. We like questions. And actually, I'm going to frame this talk around some questions. What and how? What is applied computing? And how is the course put together? Now, there's another question, and it's the one we least ask ourselves. And I'm going to explore that first. Why? Why should you study computer science? And by extension, why should you study applied computing at WIT? So perhaps you're already very knowledgeable about ICT, that's Information and Communication Technology. You might have been coding for a few years and you know that this is an area you'd like to work in. But that's great. Skip on in the video to where I talk about the structure of the degree. But that's not most people. Most people don't know a lot about the IT industry other than naming some of the headline multinational companies, most of whom have a major presence here in Ireland, whether that's Apple in Cork or Microsoft or Google in Dublin or Red Hat here in Waterford. However, IT is an integral part of pretty much every discipline. Science, engineering, business, finance, medicine, art, culture, you name it. One of the biggest employers of tech graduates in the southeast is Glanbia. And the people there work on things like food product development and agri-tech research and marketing. And they're figuring out new ways for us humans to feed ourselves better. You only have to think about it for a moment to appreciate just how much technology underpins our daily lives and the extent to which we rely on it. It became even more apparent during the COVID-19 pandemic. Now, I can blitz you with figures about salaries and how computing graduates earn more money than other graduates, or about how many jobs are on offer here in Ireland and internationally. But you can just take that as a given. You can look it up if you want, and I'd recommend checking out the Grad Ireland Graduate Salary and Recruitment Trend Survey, because there's loads of data in that. For me though, there's three main reasons to study computing. Firstly, it's a discipline that crosses pretty much every other discipline. You can work in pretty much any area with a computing qualification. Me personally, I've worked as a web developer for a bank and for one of the big four accountancy firms. I also worked as a programmer for a data science company looking at natural language processing and unstructured search. I recently did some audio work for a virtual reality game, which I really enjoyed. I've worked in IT for a theatre company and also a radio station. My point isn't to list off my CV. It's to make the point that computing isn't always about computers. It's about how computer science and technology can be applied to solve problems in other areas, whether that's finance or music or agriculture or medicine or whatever. Anything you're interested in, you can be sure that technology is in there somewhere. Now, the second reason I think you should choose computing as a career is that it's constantly changing. I can guarantee you that you won't be doing the same thing for the rest of your life if you choose a career in tech. As the technology evolves, you'll evolve with it, learning new skills and working in areas you never even thought of. In the last 5 years, I've learned about 3 new programming languages and worked with technologies that didn't even exist 10 years ago, never mind back when I was a student. If you like to try new things, this is a great area to be in, where you can bring your technical skills to areas that need your expertise. Right now, I'm involved in a project about gender representation. Now, if you said that to me a couple of years ago, I wouldn't have believed it. But it's a great project, it's really eye-opening and interesting, and it's wonderful to be able to contribute technical skill to such an important area. So if you want a job where you do the same thing every day until you retire, then computing is not for you. Now, the third reason I think you should seriously consider studying computing is that it's a golden passport for travel. We have graduates working all over the world, and I don't mean forced emigration or anything like that. If you want to see the world, well, tech is a great way to do it with some money in your pocket. Personally, I've lived and worked in the UK and Australia, and while working here in Ireland in tech, I've travelled all over the place, mostly European countries, the US a few times. I'm keen to get to some Asian countries in the next while, and there's plenty of scope for that once we're out of this global pandemic. My point is that if you're interested in seeing the world, a good computing degree can be your passport to travelling across the globe. There's lots of other reasons why you might want to study applied computing, such as you're into logic puzzles, or you want to work with the European Space Agency on guidance systems. But for me, the interdisciplinary nature of the applications, the fact that the discipline is constantly changing, and the opportunities for travel are pretty attractive reasons. So, now that we've explored the why, let's look at what applied computing is. So, it's a 4-year Level 8 Honours Computer Science program. It's called Applied because we focus heavily on practical elements of computing, such as programming or networking. Of course, we also look at the theoretical underpinnings of computing. I mean, it's called computer science because it's a branch of science, originally growing out of physics and mathematics, as well as some engineering disciplines, electronic and electrical engineering. One of the main differences between this program and other computing degrees is that I think we have the right balance between the fundamentals and the practical skills. That means that when the technology changes, and it will change, you should have a good understanding as to what's going on underneath the hood so that you can change with it. An important point to note is that we assume no prior knowledge or experience. We start from position zero. If you've built some websites before or mucked about with some coding, that's great, but it's not necessary. We start at the beginning and we move forward together. Actually, sometimes people who've hacked together some bits before are the ones who get into trouble because they think they know it all already, so they skip class, and then they realize they have gaps in their knowledge, they've missed loads of stuff, and they find it difficult to catch up. So this is just a nice way of me saying it's important that you show up for class. This is the structure of the course. Now, the image is probably too small in your screen to see the detail, but this information is all available on the Applied Computing page on the WIT website in a slightly different format. What you see here are a bunch of modules that follow on from each other. Now, these are mostly grouped in thematic areas. Now, a module is just another name for a subject or a class. Each academic year is divided up into 2 semesters, and typically there's 6 modules per semester. Now, these green ones here, these are all about software and web development, programming, coding. And this runs throughout the entire course. We also have some computer science, network and cloud elements. We have some theoretical components around mathematics and physics. They're more heavily weighted towards the start of the course, and they drop off as dedicated modules later on. But what you learn here underpins subjects that you might take in 4th year, such as data mining. There's a misconception that you have to be some kind of a maths genius to study computer science. This is not true at all. But it is true that there's a relationship between mathematical ability and computing, in the same way that there's a relationship between maths and people who like logic puzzles, or mathematical patterns and music. The minimum entry for requirements on applied computing are an O3 or a H7 in the Leaving Cert Mathematics. These are reasonably modest and certainly achievable. Is it a case that we sit around doing equations all day? Absolutely not. However, the discipline of mathematics helps you to get into the mode of algorithmic thinking. This allows you to become a good programmer and ultimately a successful computing professional. Now, we recognise that some students are afraid of maths, But those fears are unfounded. We find that about 90% of students who show up for class and engage with the material get on fine. We also have a Computing and Maths Learning Centre which provides extra and free tuition for students who are having a bit of trouble with maths or programming. Normally this is a large classroom that you can visit, but during COVID they moved the services online and it seems to be working out fine. One final word on mathematics, and I don't mean to harp on about it, but this is probably the most frequently asked question we receive. I doubt you'll find a computer science degree anywhere that's worth its salt that doesn't have a mathematics component. It's part of the discipline, but it's probably more accessible and achievable than you think. Now, you might also notice there's some gaps here that are marked elective. This is because we have a number of streams available on applied computing from which you can choose. These are cloud and networks, computer forensics and security, game development, Internet of Things, and automotive and automation systems. Now you can test out a specialism in first year, but then you choose one to study from second year onwards. The benefit of this is that you make a more informed choice come second year. For example, a lot of people think that they'd like forensics and security because they've seen a movie with some hackers in it. Or people will think they'd like games development because they love playing FIFA or The Outer Worlds or something. But an area like the Internet of Things, you mightn't even know what that is. Or network and cloud can seem completely abstract. But the idea is that by the end of first year, you'll have been exposed to all of these things and you'll have a much better idea as to what they're all about. And you'll be able to make a more informed choice. This is the major benefit of the common entry system. I'm not going to go into detail on each individual module because the video will be way too long, but I'd like to point out two things. The key skill you'll get from this course is programming or coding. You can see we have a lot of modules in it. We focus on traditional enterprise development, web development, app programming. Basically, you'll be what's known as a full stack developer by the time you graduate. That's somebody who can code all parts of a distributed system. That's like the web front end, the server back end, and everything in between. The second thing that I'd like to point out is that semester 6, which is in third year, looks like it has a big gap in it, but it doesn't. This is what we call the flexible semester. Here, students engage in a semester of work outside of WIT. For most people, they go on work placement. That's taking a job with a tech company. Sort of like an internship, but the big difference is that with computing students, they're typically paid whilst on placement. Other options include some development work with an NGO, professional certification, or Erasmus, which is a study abroad program at one of the many European universities that we have relationships with. Now, up until 2020, this was gaining in popularity each and every year, but Erasmus has been put on hold for the time being. I'm confident that this will be back up and running once the pandemic passes. So, what should you do next? Well, you should look up stuff and ask questions. The more information you have, the more informed you'll be and the better choices you'll make. There's a world of material about computer science education out there on the internet. So search engines, Google, they're your friend. If you've never programmed before, maybe you want to try something out. Have a look at one of the browser-based activities on code.org. Now, code.org, they're a group who promote computer science education. They're encouraging more people to take up the discipline because, well, we need more people to take up the discipline. There's a bunch of free, super accessible activities up there right now. Many of them are quite short. They take less than an hour. So you don't need to put in a huge effort to trying one of these out. You should also check out tssg.org, which is a research group in WIT that the Applied Computing program is very strongly linked with. They're about to rebrand as the Walton Institute, but the existing web domain will just bring you over to the new page when the switchover happens. It's not that research is something you'll jump into straight away, but it's good to know that there are postgraduate study options right here if you want to work towards a master's degree or a doctorate. Finally, I'd recommend you take a listen to our podcast, The Machine, in which we talk about computer science education and break down topics for novices. Recently, we've published episodes on how the COVID tracker app was built by Nearform, who are a software company based in Tramore in County Waterford. We also had an episode on a beginner's guide to cybersecurity, as well as an episode about space research that's being conducted in this part of Ireland right now. You'll find The Machine on all major podcasting platforms like Spotify or Apple Podcasts or Acast. So that's about it. I'd invite you to browse around the WIT website, read about the Applied Computing degree, and if you have any questions, you can get in touch with us. Computing.ie is probably the best email address, or you can contact me, Rob O'Connor, directly on roconnor@wit.ie. I mightn't be able to get back to you straight away, but I will get back to you. We regularly host open events, which are all virtual at the moment, so keep an eye out for details on those as they're coming up. So, thank you for watching this video. I hope you found it useful, and perhaps next year you'll be studying computer science with us on Applied Computing. Cheers.